Hello students, welcome to Sreenath Academy. In this video, we are going to discuss the 6th chapter from 8th class CBSE Max. Which is nothing but squares and square root, students. Okay, so my name is Karthik Nune. We are creating videos on all chapters and all subjects from class 6 to class 12. So please do subscribe our channel. Also like and share our video, students. So we are providing tuitions also, both online and offline. So for the tuitions, please contact description. Okay students, so without wasting time, we are going to start this session. So 6th chapter, that is squares and square roots. Now we'll start this chapter, students. So before we are going to learn all this chapter, let's go through the overview of this chapter. After that we will discuss each in detail. That's it. So in the introduction, so what is meant by a square number, we are going to learn about that in this first introduction. And next thing is, square numbers have some properties. What are those properties of square numbers? We are going to discuss about that. And after completing it, some more interesting patterns. So there are some patterns regarding the square numbers, friends. Those will be learned and understand by us, students. Okay, that is the thing. And next topic is finding the square of a number. So if I give you a number, how to find the square of that number? There are Pythagorean triplets also in that subtopic, students. Next thing is square root. So square number and square root, what is the difference between those? So we will learn about those things, students. And how to find the square roots, we are going to discuss about it also. So we will find square roots in different ways, through prime factorization, through repetitive subtraction, and through division method also. That is the thing, students. And some examples. After that, square roots of decimals. We are going to learn about this also, how to find the square root of decimals. So, and how to estimate the square roots. So this is all things we are going to learn, students. Okay, this is the whole chapter we are going to learn now, students. Hope you have understand it. So now we start the whole chapter discussion, complete discussion. So chapter name is squares and square roots. So this is our present chapter name. So in the introduction, students, so have you ever find out the area of a square? So area of square, we write it as side into side. Side means length of the side. Okay, students. So suppose there is a square and whose side in centimeters, whose length in centimeters is 1. Then what is its area? It is obviously 1 into 1. That is 1. And we can write it as 1 square. And if the length of the side is 2, and what is the area of the square, then it must be 2 into 2, that is 4, and we can write it as 2 square. And 3, same thing, 3 into 3, 9, 3 square. So if you see like this, we can write any number, we can multiply any number with that same number, and we can write it as square of that number. So if you take here a, and what we are going to do means, we will multiply that a with the same number. That is, again we are multiplying that number with the same number. So a into a, and we are calling it as a square. So square of that number. So this is called as square number. Okay, students. So in the examples, 2, 4. So there is no 4. There is 4. And 9 and 25 and 16. So all these are the square numbers, students. Why? 4 can be written as 2 square, 4 can be written as 2 square, 9 can be written as 3 square, and 25 can be written as 5 square. So these are the square numbers. So any number which you can write as square of that number or multiply number, we call it as square numbers, students. Okay, so or simply any number can be represented as product of two numbers is called as a square number, and the product must be contains the numbers itself only. Product of the numbers with itself, it is the square number. So in general, if a natural number m can be expressed as n square, where n is also a natural number, then m is a square number. Have you understood, students? If you can write m is equal to n square, which means m is a natural number, n is also a natural number. So our example is 4, we can write it as 2 square. So this is the square number. Like this, students. And we can write 25 equal to 5 square, 36 equal to 6 square. So this is called a square number. And so if you write 1 into 1, it is a 1, 2 into 2, it is a 4, and 3 into 3, it is a 9, 4 into 4, it is a 16, and 5 into 5 is 25. So can you write like this? Yes, we can write. After 5 there is 6, and 6 into 6 is 36, and 7 to 7 is 49. So the square number is 36, the next square number is 49 itself only. So there are some numbers between 36 and 49, but those numbers we don't call them as square numbers. Okay, students. So like this, can you find the square numbers between 1 and 100? I have found out up to 50. Continue this process to 100. So the numbers 1, 4, 9, 6 are square numbers. These numbers are also called perfect squares. So 1, 4, 9, 6, this type of numbers are square numbers, and we also name them, or we also call them as perfect squares also. That is the thing, students. So after completing it, those square numbers have some properties. What are those properties? We are going to discuss about those properties. So here there is a table, and there are numbers starting from 1 to 20, and for every number we have written the square number. For 1 it is 1, for 2 it is 4, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, like that. So if you carefully understand these things, in that if any digit in the square numbers, if you see, all these ends with some numbers, the units place. Carefully observe the units place of square numbers. What you understand? There are only 0, 1, 4, 5, 6, 9 at the units place. Here 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. So 0, 1, 4, 5, 6, 9. Only these numbers are there at the units place of the square number, students. That is the one thing you have to remember. And there is any number which is ending with 2, 3, 7 or 8 in the units place. Okay, students, this thing you have to observe. So this is one of the interesting thing, students. So next is so here also the same table. Here the numbers are from 1 to 10, and from 11 to 20, and from 21 to so 50. Here after 25 there are 5 numbers only. So if you observe these things, if you carefully observe these square numbers, 181, 121, 361, 441, all these ends with 1. Their units place is having 1. So if you find out the number for it, it is 1. So square of 1 square is 1, 9 square is 81, 11 square is 121, 19 square is 361, 21 square is 441. So whenever there is 1 or 9 in the number, then there must be 1 in the square number. If a number ends with 1 or 9, then it's a square number ends with 1. This is the one of the interesting property. And if you consider here, so if there is 4 or 6 in the one units place of a number, then its square number have 6 in the units place. If you can see here, this is the thing. So now observe these squares. Here 10 square equal to 100, 20 square 400, 6 square 400. So if we see here, in these things we are having 1 0, but in the right hand side there are 2 zeros, and here there is 2 zeros, and here we are having 4 zeros. Suppose if a number contains 3 zeros, and how many numbers it will have here? So obviously it is a 6 numbers like the students. Okay, so what do you notice about the number of zeros at the end of the numbers and the number of zeros at the end of its square number? So what you can say about the squares of even numbers and squares of odd numbers? So there is, try these examples you can solve, students. So we will see some interesting patterns here. So first pattern is adding triangular numbers. If you add the triangular numbers, here this triangle is added, or this triangle is added, this triangle. If you see here, there is 1, and here there are 3 dots, and here there are 6 dots, and 10 and 15 like that. So if you add these two things, you will get square number. If you add these two things, you will get square number. If you add these two things, you will get square number. If you add these two things also, you will get square number. We know if you add this, 1 plus 3 is equal to 4, 4 is a square number, 3 plus 6 is a 9 is a square number, 10 plus 16 is a square number, 15, 25 is a square number. This is one of the interesting thing. And numbers between square numbers. So if you see here, students, here there is 1, and we can write as 1 square. So 1 square. Next thing is 2 square. So 2 square value is 4. So from 1 square value is 1. So between 1 and 4, how many numbers are there? 2, 3. 2 numbers are there. And next thing is 3 square equal to 9. How many numbers are there? 5, 6, 7, 8. And it is the 9th number. So if this process goes, and here the question is about how many non-square numbers are there between consecutive or successive square numbers. 1 is the square number and 4 is the square number. These two are the successive square numbers. So between these two successive square numbers, how many non-square numbers are there? Here 2 and 3 are the non-square numbers between these things. And coming to 4 and 9, these two are the successive square numbers. And how many non-square numbers are there between these two successive square numbers? So between these two things, 5, 6, 7, 8, 4 non-square numbers are there. So like that, if you moves on like that, what we can conclude is that, students, from all these observations, if we think there is a natural number n and n plus 1, n it one number, n plus 1 is another number. Between these two natural numbers, how many non-square numbers are there? So between these two natural numbers, that is n and n plus 1, we are having n plus 1 whole square minus n square. That is n square plus 2n plus 1 minus n square. Then you will get n square will get cancelled. 2n plus 1 you will remain plus 1. Finally, what we can say is that, students, we have 2n non-square numbers between n and n plus 1. So between these two numbers, natural numbers, how many non-square numbers are there? There are, between these two square numbers, there are 2n non-square numbers. Okay, students. Thus in general, we can say there are 2n non-perfect square numbers between the squares of the numbers n and n plus 1. Squares numbers. So not between n and n plus 1. The numbers between n square and n plus 1 whole square. Between these two square numbers, how many non-square numbers are there? There are 2n non-square numbers between n square and n plus 1 whole square. Not between n and n plus 1. So adding odd numbers. So what happens here? 1 is the odd number and we are going to add 3 to it. 1 plus 3 it gives 4, and if we add 5, 1 plus 3 plus 5 it gives 9. So 1, 4, 9 are the first three square numbers. 1 square, 2 square, 3 square. So like that, if you going on adding the odd numbers, you will get n square. Okay students, so sum of the first odd natural numbers is n square. Sum of first odd n natural numbers is n square, students. This is the thing. Here we are only adding the odd numbers starting from the beginning. It will give rise the n square, students. So now consider those numbers which are not perfect squares. Say 2, 3, 5, 6. These are not perfect squares. So can you express these numbers as the sum of successive odd natural numbers beginning with from? No, we can't express things. Now consider the number 25. Successively subtract 1, 3, 5, 4, 7, 9 from it. What happens? So if from the 25 onwards, if you subtract 1, it is 24, and from it 24, from it if you subtract 3, 4, and it is 21, and 21 minus 5 it is 16, and 16 minus 7 it is 9, and 9 minus 9 it is equal to 0. How many steps? 1, 2, 3, 4, 5. So we can also say that if a natural number cannot be expressed sum of successive odd natural numbers starting with 1, then it is not a perfect square, students. So this is the thing. So next thing is sum of consecutive natural numbers. So if you add sum of consecutive natural numbers, what happened? So 3 square is equal to 9, and we can write it as 4 plus 5, and we can write it as the 4 as 3 square minus 1 by 2 plus 3 square plus 1 by 2. That is 4, and this is 5. We can also write 5 square equal to 25, and that is equals to 12 plus 13. And we can write 12 as what? How we can write it as 12, students? So we can write it as 4 square minus 1 by 2. So it is not 4 square minus 1 by 2. So 3 square is 9, 9 minus 1. So 5 square So how to write this? See here, 3 square equal to 9, and you can write it as 4 plus 1, 5, and 5 can be written as what? 4, and 4 can be written as 3 square minus 1 by 2. Like that. So you will get 9 minus 1. It is 8 by 2, 4. Here if you want to get 12, that is 5 square minus 1 by 2. 5 square is 25, and minus 1 is 24. 24 by 2 is 12, and 5 square plus 1 by 2. That is 25 plus 1 is 26. 26 by 2 is 13. Like that we can get, students. So next thing is product of two consecutive even or odd natural numbers. So here is the product, and what we are doing is product of two consecutive even or odd natural numbers. Let's come to this. 11 into 13, we know that it is 143, and we can represent it as 12 square minus 1, and we can also write it as, and we can also write this 11 as 12 minus 1 and 12 plus 1, and 12 minus 1 into 12 plus 1 is also gives rise the 143. So finally 12 minus 1 into 12 plus 1 can be written as 12 square minus 1. Okay students, like that you can write the 11 into 13 or 13 into 15 or 29 into 31, like these things, students. Okay, so what is in general means a plus 1 into a minus 1 equal to a square minus 1, a plus b into a minus b equal to a square minus b, like this, students. Okay, that is the case. And some more patterns in square numbers. So if you observe, students, we find the 1 square, it is 1, 11 square, it is 121. It is a beautiful pattern, students. If you do the 1 square, it is 1. If you do the 2 square, so not 2 square, if you do the 11 square, it is 121. And triple 1 square, it is 14242. Sorry, it is not 4, and it is 12321. How I can remember it means simply write this pattern 1 2 3 1 2, and if you want square, you can write 1 2 3 4 3 2 1. So it will explain like this, students. So it is very easy and very beautiful. And another interesting pattern we are having is regarding the 7 square. So if you go and see the 7 square, 7 into 7, 7 square, that is equal to 49, we know it. And if you do 67 square, it will give 4489. Like the 667 square, it gives like that. So this is the interesting about numbers, students. So that is the thing. So now the question is finding the square of a number. So if somebody gives you a number, and how to find the square of that number. So squares of small numbers like 3 4 5 6, we can easily find them. If it is 3, so 3 into 3, that is equal to 9, 9 is the square number. And if it is the 4, 4 into 4, and if it is the 5, and 5 into 5, we can write. But if there is a number 23, how can you quickly do it? So multiplying with 23 into 23 takes too much time. So how to do this task? So for that, 23 into 23, we can do it as 20, we can write it as 20 plus 3 into 20 plus 3. We can write them as 20 plus 3 whole square. Basically also, if you write it them like this, so starting from it, from the starting, 23 can be written as 20 plus 3. Then 23 into 23 can be written as 20 plus 3 into 20 plus 3, that is 20 plus 3 into whole square, and we can write it as 20 plus 3 into 20 plus 3. And if you just do the multiplication, that 20 into 20, 20 square, plus 3 into 3, that is 3 square, and 20 into 3, that is 20 into 3, and plus 3 into 20, that is 3 into 20. So simply 20 square is 400, we know it, and 3 square is 9, and 23 is 60, and here also 320 is 60. Simply we can get that is 120 and 400, that is 529. This is the way, students. Okay, here are some examples. There is example 39 and 42. 39, how to find it? Example 1, that is regarding 39 square. We have to find out the 39 square. How we can write it as? So in two ways we can write it, students. One thing is 30 plus 9 whole square. Otherwise, in the textbook it is 30 plus 9 whole square. So I wish to write it as 40 minus 1 whole square. It is most easy for us. We can write it as 40 minus 1 is how much, students? So that is nothing but 39. We can write it as like that also. So we can write it as 40 minus 1 into 40 minus 1. So 40 into 40, which is 40 square, or otherwise you can simply write 40 into 40 minus 1 into 40 minus 1, multiplying this with whole term and this with whole term. So 40 into 40 is 40 square, minus 40 into 1 is 40, minus 1 into 40 is 40, minus into minus plus 1. You can write them it as 40 into 40 square is 1600, and that is minus 80, and this is plus 1. If you subtract it, you will get 1521. That's it. Here also answer is also same. So other patterns in squares. So if we see here, we favorite number is 25. So 25 square is 25 into 25, that is nothing but 625. And if you want to write it as, how we can do this task, that is, here there is 2, so 2 into 3 into 100 plus 25. So 2 into 3 is 6, 600 plus 25, 625. And if there is 35 square, can it as 35 into 35, and we can, its value is 1225. And if you want to get it simply, so there is 3 and the next number is 3 into 4, so 3 into 400 plus 25, so that is 1200 plus 25, 1225. That's it. Like this you can do for 75, 125, all these things. Pythagorean triplet. So we know Pythagoras theorem. If it is the right angle triangle, so if it is the opposite to the right angle triangle is hypotenuse, it is the side and side. We know one formula in the Pythagoras theorem, that is hypotenuse square equal to side square plus side square. So the values which suits this relation are called as Pythagorean triplets. Suppose if you take here it is 5 and it is 3 and it is the 4, so then we know that 5 square is equals to 3 square plus 4 square. It is called, and then 3 comma 4 comma 5, this set we called as the Pythagorean triplet. So we know 5 square is 25 and 3 square is 9 and 4 square is 16. If you add 9 plus 16, you will get 25. So it's satisfying the Pythagoras theorem. So it is a Pythagorean triplet. So another thing which is like that is 5, 12, 13. This is another triplet. And 5 square is 25, 12 square is 144, and 13 square is 169. So if you add these things, you will get this. It is another triplet. So these are Pythagorean triplet, students. So can you find more such triplets? So for that there is a shortcut formula for it. Suppose we must have the natural numbers only. In this case, we can write 2m whole square plus m square minus 1 whole square is equal to m square plus 1 whole square. This is the rough thing you have to imagine. So what are the triplets here? 2m is one thing and m square minus 1 is another thing, m square plus 1 is 1. So if you have any number, say 3, like that, m equal to 3, then you will get Pythagoras triplet associated with it. So how we can get, if you do it, you will get that is 6m and 9 minus 1 8 and it is 10. I think 3 square is 9 plus 1 10. So this is the Pythagorean triplet. So simply if you do like this, students, you will get, so it will get, gives you 36, it will gives you 64, it will gives you 100. So if you add these two things, you will get 100. That is the trick you can use, students. So here is an example. Write a Pythagorean triplet whose smallest number is 8. So we have to write the Pythagorean triplet. That is the main question. And how to we write the Pythagorean triplet is, they have given you some clue that whose smallest number is. So a Pythagorean triplet means there are 3 numbers. So out of these 3 numbers, there is one number which is very smallest number, and that smallest number is 8. So what are the numbers we are having basically is 2m, m square minus 1 and m square plus 1. Out of these, which is the smallest one? Suppose we can take it is the smallest one. So m square minus 1 they have given as 8. So obviously m square equal to 8 plus 1, that is 9, m equal to 3. So once you know the m, and next 2m is 6 and 9 minus 1 is 8 and this is 10. 9 plus 1 is 10. This is the thing, students. So here also you can find out easily. Here also the Pythagorean triplet is there, and here also one number is 12. You can do this task on your own, students. Next we are coming across the square roots. Okay, so we have started our discussion where means, so if you know the length of a side, then what is the area of that area of that square? If you know the length of a square, and what is that area of that square? That is side square of the number, like that. Now coming to the, if area is given, and what about the side length? If the area is 144 centimeter square, what is the length of its side? So we know that area equal to side square. So we will trial and method. So 5 5s, it is 25, not 144. Like 9 9s, 81, not 144. Like if you do trials, you will get 12 12s is equals to 144. So 144 is the area. So 12 into 12 is the side square. So each side length is 12. You can write as 12 into 12. Side length is 12. So if you know the area, if you want to know the side length, what we have to do is, we have to find the square root of it. Okay, students. How you get the square root, we will learn about that, students. Okay. Next thing. What is the length of the diagonal of a square of side 8 centimeters? So there is a square whose side is 8 centimeters, and we want the length of the diagonal. So if it is 8 and it is also 8, then you can apply the Pythagorean theorem. So it will gives you the 8 square plus 8 square, that is equal to 64 plus 64 equal to 128, that is equal to AC square. But what we want here is AC square, that is equal to hypotenuse square, is equal to 128. Okay, but what is the length of, we want just for hypotenuse, only side length, not the square number. Then how you can convert it? You find h square equal to 128, but what about the h value? How you can do it? So this is the square number. This is called as finding the square root. If you find the square root, you can say square root for 128, you can know the answer. That is the thing, students. Finding square root. So how we can find the square root? So basically what we are having is, the opposite operation of addition is subtraction, and for multiplication is division. Like that, for square number, the opposite operation is square root. It is the inverse of it. If you add any number, if you subtract that number, you will get the same number. Like that, if you find a square number of any number, and if you find the square root of that square number, you will get that number. So 1 square, it is equal to 1. 2 square equals to 4, and here square root is 2, and 3 square, it is a square number, you can write it as 9, and you can write it as 3 into 3, and its square root is 3, and 4 square, it is equal to 16, and we can write it as 4 into 4, and square root is 4. So by doing so, you can observe, we can express the square number. We have already defined the square number like that only. We can express the square number as the product of it and itself, and one of that product is the square root. That's simple. It is the inverse operation of square number. So if you see 1 square equal to 1, it is the statement, but what is the inference of it? What is the opposite of it is, if you find the square root of 1, that is equal to 1 only. 2 square equal to 4, then what is the square root of 4? What is the square root of 4? That is simply 2 only. And 3 square equal to 9, and what is the square root of 9? That is 3 only. So this is called as square root, students. So here we will find out how to find the square roots using different methods. Finding square root through repeated subtraction. Here we will find the square root through the subtraction method, students. Okay. So what you have understood, what you have learned in the previous things, sum of first and odd natural numbers is n square. Sum of first, suppose if you add 1 plus 3 plus 5 like that and so on, n, you will get n square. That is the case. So from that, here we have to find the root for 81, a root for 81. So first thing is we have to subtract the odd natural numbers. 81 minus 1 is 18. Again 80 minus 3 is 77. Again 77 minus 5 is 72. Again 72 minus 7 is 65. Again 65 minus 9 is 56. Again 56 minus 11 is 45. And again 45 minus 13 is 32. Again 32 minus 15 is 17. Again 17 minus 17 is equal to 0. So whenever you are getting the 0, it is the end of the subtraction process. So how many steps it takes, how many times, how many odd natural numbers we have subtracted? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 successive odd natural numbers we have subtracted. So the square root of 81 is equal to 9. That's it. So simple. But what problem is that, students, if you want to find the square root for 729, what happens? If this process goes on like this, what happens? So it will get a very long process. So it is difficult. So we don't use it. We have to find a better way. What is the better way? So here there is a better way, students. Next method is finding square root through prime factorization. Suppose if you take a number 6 and if you find the prime factorization of it, how we can write it as 2 into 3. And if you take the square number of this, that is 36, we can write it as 6 into 6 or 2 into 2 into 3 into 3 is the prime factorization. So if you clearly observe, and coming to 12, okay students, 12 can be written as 2 into 2 into 3. And if you find out the square of this number, that is 144, and you have to write it as 2 into 2 into 2 into 2 into 3 into 3. So what is the difference between square and square number? How we can convert them both? If you see, for every pair there is one number only. Here 2 comes 2 times, but we have taken 1 time. 3 comes 2 times, but it taken 1 time. Here also 2 comes 2 times and we taken 1 time. 2 2 times 1 time. 3 2 times 1 time. Like that. So this is the case happening here, students. Okay. So what we can understand is that, students, for a square number, after doing the prime factorization, if you want the root of it, what you can do is you can take 1 out of these two. In 3 by 3 you can take 1, and 2 by 2 you can take 1, 2 by 2 you can take 1 out. Like that you can do the things, students. Okay. So 324 is the, here we are going to find out the 324 is the number, and we are going to find out the factors for this number. Okay students, for that first we have to find out the prime factors. 324, 2, 1 time 2, 1 time 2, sorry 6 times and 2 times, and 8 2s are 16 and 1 2s are 2, and again we know 4 2s are 8, and it is 1 4 2s are 8, but it is not cancelled, so we have to shift for 3. So 3 2s are 6, and there is 2 21, so 7 3s are 21. Again 3 table, that is in 9, and again 3 times. We have to write these things, and what if you write these things, we have to make 2 as a group. So these 2 as group, these 2 as group, these 2 as group. Out of group you have to take 1, pick up 1. So 1 2 3 and 3, multiply these things. 2 into 3 6, 6 into 3 18. So 18 is the, so square root of 324 is equals to 18. That's it, students. Like that you have to do. We will solve some problems here. So if you take here, find the square root of 6400. So if you write it and if you do the task, you will get this as the prime factorization. You know the prime factorization. So every time you have to take out of these two 2's, we have to take one. These two, take one. These two. So I am going to, from these two things we have to take another one. These two things we have to take one. 1 2. For these two 1. For these two 1 2. For these two 1 2. For these 5 2 5 1 5. Like that you have to pick one out of the two and multiply remaining things. You will get 80. Now the question is 90 a perfect square? Is 90 a perfect square or not? How we can know whether it is a perfect square or not? So for a perfect square, so if you find the prime factors for a perfect square, so all factors like repeats twice time, we can make all of them as groups like this, students. For 90 also, if you do like this, and for 90, 2 into 45, 3 into 15, 3 into 5 you will get. So if you see here, we only make 3 into 3 as a group, but not 2 and 5. So there are no another terms, same 2 and 5. So it is not a perfect square. Can you understand it? So now we will find out. We have completed this and we will target on this. So find the smallest number by which 9408 must be divided so that the quotient is a perfect square. So first thing is that, students, there is a number is 9408. So we have to divide this number with some number we don't know about, let it be x, so that you will get some number, maybe y. It is a perfect square and it is a perfect square. And for this perfect square we have to find out the square root. So looking at this, you may think it is a very tough problem, tough process, but it is very easy, simple. So one thing is we have to find out this number. Later all this will be done within seconds. How to find out this? So what is the main thing is, it is not a perfect square. That is the confirmed thing, and it is not the perfect square. So what we know about perfect square, if you do the prime factorization, so in the prime factorization for a perfect square, what happens is every factor will have, we can make all factors into two groups. If you can't make them into two groups, it is not a perfect square. So first we will try to find out the prime factorization of this. So if you do like this, you will get that is 2 into 2 into, here it is. If you want, you can do it by your own, but due to lack of time I am completing this. So 2 into 2 and 2 into 2 and 2 into 2 and 3 into 7 into 7. So this is the prime factorization for this. So in the prime factorization, what we will do is to make to find the square root or whatever it may be, we will make 2 as group. So this 2 as group, this 2 as group, this 2 as group, and these two things as group. What is the remaining is this 3 is remaining. If you have any another 3, we can make them as group and we can get 1 out of it, and multiplying all the ones we will get the square root. So now it is not a perfect square root. How we can make it as a perfect square root, students? So if either by multiplying with another 3, you will get a 3 into 3 one group, so that we can take 3 as 1, it will become a perfect square. Nor remove these 3. In that case also there are remaining only these things are remained, and you can make them and you can get the perfect square out of it. So what he is asking, what is the smallest number which we have to be divided? So we have, if you divide with 3, these 3 will cancel and you will remain with these numbers only. So if you multiply these 3 things, you will get some another number, and that is the perfect square. And what is the square root of it? We know that number, for that number also these are only the prime factors. So from out of it we will take 1 1 1 1. So it is the 2 and it is the 2 and it is the 2 and it is the 7. Multiply 2 2s are 4 and 4 2s are 8. So 8 into 7. 8 into 7 is 56. It is the square root. And what is the number? And we have to divide it with 3. So that is the thing. You can do this also like that. So finding square root by division method. There is another method. Here we are going to follow, students, which is nothing but division method. How we can do this thing? So first, if you see here, this is the number 10 and the square of it is 100, 31 and it is 961. So what is the signification of both these numbers? So 100, which is the smallest 3-digit perfect square number. So there is no perfect square number which is smaller than this. And coming to this, it is the greatest perfect square having 3 digits. Beyond this, there is no another greatest 3-digit perfect square number. So all the 3-digit perfect square numbers lie between these two things only, these two numbers only. Okay, students. So all the 3-digit perfect square numbers must have the roots between 10 and 31 only. And between 10 and 31, we will have only 2-digit numbers only. So all the 3-digit perfect square numbers will have 2-digit roots, square roots. All 3-digit perfect square numbers will have 2-digit square roots only. And it is the 1024 and it is the 9801. So it is the smallest 4-digit perfect square and it is the greatest 4-digit perfect square. So not only for all 3 digits, for all 4-digit perfect square numbers, their square roots must have 2 digits only. So for 3-digit perfect squares, their square root have 2 digits. For 4-digit perfect square, their square roots have 2 digits only. Like that, what about for 5-digit and 6-digit perfect square numbers? Think of them. So here we will find the square root using a division method. Okay, students. So what is the number? 529. It is the number. So first thing is we have to make them into groups. Starting from the units place, we have to make two digits as a group. So these 2 digits as group and these 2 digits as group. But if it is having only 1 digit, so no problem, make it as a group. And next thing is starting from the left, which is from hundreds place or whatever the highest place. What you have to do is, so first we have to pick up the first group. So here in the first group we are having only one number. So we have to find out for a number whose square, find out for a number that is x, whose square gives rise the value which is less than or equal to that first group number, that is 5. So 2 square is 4 and which is less than or equal to 5. So we are taking 2 and we are writing the 2 in the divisor and in the quotient. So 2 to the 4. Next thing you have to do the subtraction. You will get that is 1 and you have to bring these two numbers down. It is the 129. And what now we have to do is multiply this number twice, double this number, that is 4, and there is a space here, box here. So here we have to place some number and that same number you have to place here also, and whenever you multiply these two numbers with this, if you place here some number, if you place here x and if you place here x, and for 4x into x must give it the number which is less than or equal to 129. Like that you have to find out for one number, and that number is what? And that number is what, students? If you see, that is the 2. 42 into 2, that is 84. So we'll get 84 here. Forty 20 is 84. So we will make 43 into 3. So you will get 43 into 3 is 129, which is equal to this. So we'll make it as 3. 43 into 3, 129. So if you subtract it, it is 0. So when our remainder is 0 and the coefficient here, it is 23, is the square root of this number. Therefore, square root of 529 is equals to 23. That's it, students. Like that, you have to find out this for 4096 also. We will do some problems here. Find the square root of 729 and these things. So 729. First thing is 729. You have to make them into groups like this. And again, 2 2s are 4, 3 3s are 6, 3 3s are 9. So you have to pick up for 2 2 2s are 4. And like these 3, and you have to bring them down, and you have to twice them 4, and you have to select for 7. So 47 into 7 is 329. So here square root of 729 is equals to 27. That's it. And find the greatest 4-digit number which is perfect square. So we have to find out the greatest 4-digit number which is a perfect square, students. Greatest 4-digit number which is a perfect square. So we know the greatest 4-digit numbers, the normal greatest 4-digit number is 9999. But whether it is a perfect square or not, first we have to check for it. If it is not perfect square, how can make it perfect square? So in a perfect square, all the factors are repeats. Okay, so find out the prime factors for this in this way, or we find root 19 by long division method, and you will get the remainder is 198. This shows that 99 square is less than 99999 by 198. So by doing this method, students, by doing this 99 prime factorization method, you will get, or whether in this method or in this division method also you can do. In the division method, if you make these two as group, these two as group, and you make this like this, in this way also, if you take 9 here and 9 9s are 81, like that, if you do so, you will get 1899. If you double it, 9 2s are 18, and if you make 9 here and 9 here, you will get 1701 here, and if you do subtraction, you will get 198. So it is the remainder. So if you get the 0 as the remainder, then it is a perfect square, but we are getting 199 is as remainder, so which is the extra term. So if you subtract this 198, you will get the remainder 0, then that number will be a perfect square. So you have to subtract 1998 from 999, you will get 9801. So it is the greatest 4-digit number which is a perfect square. So for this, we have to find again this thing, and here the coefficient is this, simply it is the square root. Next, square root of decimals. Square root of decimals. So if you consider square root of 17 minus 64, the process is very same, students. First thing is we have to make them groups, and you have to look for a number that is 2 square, 4, 3 square, 4 square, 16, 4 4s are 16, and you have to subtract it, you will get 1, and again you have to take them down, and you have to double it, that is 8, and you have to check for number. So what is that number? That is 2. When multiplied by 2, and after doubling it you have to put the dot here. Why? Because we are going out, going beyond the dot, no decimal point. So 82 into 2, 82 2s, that is 164. Final remainder is 0. So 4.2 is the square root. Therefore square root of 17.64 is equals to 4.2. That's it. Area of a square plot is 2304 meter square. Find the side of the square plot. So he is asking you students, 14th example, area is equals to 2304. Area means side square, it is 234. Then what is the side length? So it is nothing but x square equals to 2304, and which is the side square. Then side is equal to square root of 2304. So we have to find out the square root of that number. And how you can find out the square root of any number? By division method you can show like this. If you do 2304 is there, make 2 as groups, and first thing is 4 4 is 16, and it is a 16 here, and what is the remaining is, that is 4 here, 3 here, that is 7, and if you take down them and double it, 8, it will becomes 8, and if you take 8 again, 8 8 8 8 is 004, simply 0, then 48 is the square root. Side length is 48. That's simple. Next thing is estimating square root. How to estimate the square roots? So here there are two situations, students. So Deveshi has a square piece of cloth of area 125 square centimeter. He is having a square piece of cloth. It is 125 centimeter square. She wants to know whether she can make a handkerchief of side 15 centimeters. So whether she can make a handkerchief because using this, and whose side length is, so if you want to make a handkerchief whose length is 15 centimeters, so its length and breadth are same, and you have to find out that area of that. So they have given the side length, and if you multiply this 15 into 15, that is what? 15 15 is what? Tell me, students. That is 225. So she can't make it. If that is not possible, she wants to know what is the maximum length of the side of a handkerchief that can made from this piece. So 15 into 15 is 225. So its area will be 225. It is not possible. It is only 125 centimeters. Then what kerchief will be possible? So in this case, how you will do these things is, basically here if you see 15 square is equal to 225 and 16 square is equal to 256. We know about it. So we will start this session. In all situations we have to what? Estimate. Okay students, we have to estimate. So here there is another thing. Meena and Shobha played a game. They have played a game. One told a number and other gave its square root. Okay. So Meena started first. She said 25. And Shobha answered class 5. So they are playing some game, students. Meena is there. And next thing is Shobha is there. So Meena will tell some number. He tells that 25. And he has to tell its square root. It is 5. And then Shobha said 81. And she has to tell the square root. It is the 9. So they are playing like that, square root. So suddenly Megha has given the 250. Then what is the answer? Square root. Square root of 250 is what? So for that, or they have to tell a TCL number which is closer to square root of this. Estimate. What we know is 250 is between 100 and 400. 100, we know that 100 is a perfect square, 10 square, and 20 square, it is a 400. So it must be between these. So but there are some other numbers which are very close to 250. Okay students. So if it is the Okay, so we have finding the square roots for all. Square root of 100 is 10, 400 is 20, and this is thing. There are some others which are very close to them. What are close to them? So we know that if you decrease it to 50, increase it to 15, so it is less than 250, and it is less than 16 also. How you know, sir? 15 square is equal to 225 and 16 square is equals to what? 256. So between these two numbers is the 250. So, and one more thing is, it is more close to 16 than 15. So we can estimate that root 250 is approximately having the square root of 16. In that way you can estimate. That's it, students. Our chapter is completed. Chapter completed. Hope you have understood well, students. If you have any doubts, please feel free to comment below. We will quickly see the summary of this session, students. Squares and square roots. So what is the square number? If you express any number as product of two numbers, then it is called a square number. Suppose if you express, if you take 25, you can express it as 5 into 5, product of the same number. So 25 is a square number. Like that we have discussed. And the square numbers ending with 0, 1, 4, 5, all these things in the units place. So every square number in its units place having 0, 1, 4, 5 like that. And if there is 1 or 9 in the units place of a number, then it's in square number, there is it ends with 1. And there are some interesting patterns here. And one thing is, so there are 2n non-square numbers between n square and n plus 1 whole square. And sum of first odd natural numbers is equals to n square. And after that, how to find the square of a number? There is a pattern we have followed. A plus and Pythagorean triplets, we know about all those things also. We solved some problems. Next, square roots. So addition is the inverse of, subtraction is the inverse of addition. Like that, square root is the inversion of square number. So area of any square is 144 centimeters square. It is the square number. And what is its square root? So side of a square is the side length of a square is the square root of that number. Like that, students. How to find square roots, we have discussed them. And by repetitive subtraction we can find the square roots, and by prime factorization we can find the square roots. And another thing is, by division method also we have find out the square roots. So later is that, students, we have estimated the square roots for decimals also. In the same process it has to be, but there is a small difference between decimal point. Next is estimating square roots. So like that we have completed this session, students. So our chapter is completed. Our chapter summary is also completed. Hope you have understood well, students. If you have any doubts, please feel free to comment below. Have a nice day. Keep smiling. Bye bye, students.